Hello GCC. We are going to look at Chapter 4 for Chem 130. It is over atoms, and it would be very helpful if you get out your periodic table to look at while we're going through this chapter. So this chapter is about atoms, and we're going to start back in 1808 when Dalton came up with his atomic theory, which consists of 5 statements about atoms. So let's look at the 5 statements and see if they still hold true today. So the first one says an element is made of tiny indestructible particles called atoms. Indestructible. Is that still true? Well, no, it's not. At the time, they thought it was true, but now we have particle colliders and atom smashers where we put atoms in and have magnets accelerate them and then put particles in their way so they collide and they make other particles. So they're not quite indestructible. So that's not quite true anymore, but that was his first statement. His second statement, all atoms of an element are identical and have the same properties. In other words, a bromine atom is the same as another bromine atom across the world. So all bromine atoms are exactly the same with the same properties. Yeah, that's not quite true either. So what's different about bromine atoms? Any ideas? If you said the word isotope, you're correct. So bromine atoms don't necessarily all have the exact same mass, and we're going to talk about that later. So this is not quite true either. Dalton's third statement in his atomic theory, atoms of different elements combine to form compounds. So if you look on your screen, we have some green atoms, some red atoms, and they're combining to make a compound with one red and one green atom. So is that still true today? Do atoms of different elements combine and form compounds? Yes, they do. Absolutely true. This statement is still good. His fourth statement in his atomic theory, compounds contain atoms in small whole number ratios. In other words, water is 1 oxygen atom and 2 hydrogen atoms. H2O, not half atoms or 3/4 of an atom. Is that still true? Absolutely true. Yeah, we can't have atoms cut into little pieces in a compound. That doesn't make sense. So compounds always have whole number ratios. Absolutely true. So that one's good. And there's a picture of carbon and oxygen as an example. For his fifth statement, we have atoms of 2 or more elements can combine to form different compounds. For example, the carbon is the red atom. Oxygen is the gray atom. We can have CO, or we can have C in the middle with 2 O's, CO2. Is that true? Can atoms of 2 or more elements make different compounds? Absolutely they can. It depends on the ratio of the atoms and how they're combined. But carbon and oxygen can form carbon monoxide or carbon dioxide. Both are possible. So number 5 is also true. Good. So 3 out of 5 are still true today. That was over 200 years ago. Dalton did a pretty good job. Moving on. So 95 years later, we have Thomson and the electron. So J.J. Thomson is given credit for discovering the electron in 1897. He determined that cathode rays are deflected by electric fields and magnetic fields. So cathode rays are composed of tiny, negatively charged subatomic particles, and he called them electrons. We give an E- as the symbol for electrons. So subatomic just means smaller than an atom. So subatomic particle, an electron is a subatomic particle. It's a lot smaller than an atom. And there is a YouTube video that I need you to go and watch. You can pause this, go watch it now, come back, or you can just watch it at the end of this. But you need to go watch that video about Thomson and his discovery of the electron because it's very interesting. He used cathode rays, which are basically the forerunner of a television tube back when televisions were big and wide, not flat screens, but the big wide ones. They had tubes in there. And by using an electric field or a magnetic field, you can deflect electrons up or down and place them where you want to on the screen. And because the electron was attracted towards a positive end of a magnet, he knew the electron was negatively charged because opposites attract. So if the little particle was attracted to a positive, it must be negative. So electrons are negative, and they're tiny, and Thomson discovered those back in 1897. So Thomson in 1904 proposed an atomic model where an atom is just this positively charged sphere, and it has electrons just poking in it, kind of scattered randomly, kind of like raisins in plum pudding, so it was called the plum pudding model. It didn't last very long, that kind of version of the atom, but that's what he proposed in 1904. So again, over 100 years ago. And then in 1911, Ernest Rutherford is credited with discovering the nucleus of an atom through his alpha scattering experiment. He shot alpha particles at gold foil, so like tinfoil but made of gold. And most of the alpha particles went straight through the foil, but a few actually bounced back, sideways or completely backwards. This was shocking. It was as surprising as like firing a gun, a bullet, and having it bounce off a Kleenex. You expect it to go right through the Kleenex, but imagine if it bounced off. That'd be crazy. Well, that's how crazy this was. The alpha particles were bouncing back off the gold foil. They should have gone straight through. So I want you to go watch this video. It's very interesting, of Rutherford and the nucleus. You can pause and go watch it now or watch it later, but I would like you to watch this YouTube video, please. So here is a picture of the explanation of what Rutherford saw. So if the atom was like Thomson thought, the plum pudding model, we can see that the electrons are just kind of randomly scattered through the atom, and the alpha particles should have just gone straight through. But if you look on this side of the screen, closer to me, you will see Rutherford decided there had to be something at the center of the atom that had some mass, and he called it the nucleus. And if an alpha particle hits the nucleus, it's going to bounce back. Now, if it's above the nucleus, it'll go straight through the atom. Below the nucleus, it'll go straight through the atom. But if it hits the nucleus, it's going to bounce back. That's why the alpha particles bounced back. They were hitting the nucleus. And again, the video explains it much better than I just did. So go watch that video. So at this point in 1917, Rutherford discovered that there is a positively charged subatomic particle, he called it the proton, in the nucleus. James Chadwick discovered the neutron, which is a neutral particle, in 1932. And so at this point we came up with the nuclear model, that the atom is mostly empty space. We have a nucleus, and what lives in the nucleus? Yeah, protons and neutrons live in the nucleus. And then there's a lot of empty space till you get to an electron, and electrons orbit around the nucleus. So every atom has a small, dense nucleus with protons and neutrons, and the electrons are moving around the nucleus, and there's a lot of empty space going on. So if the nucleus was actually the size of a marble, and you put it on the 50-yard line of the Cardinal Stadium, you wouldn't even reach electrons till you were way up in the seats. There's all that empty space between the nucleus and electrons, and then there's more space before you get to other electrons. So the nucleus is actually about 10 to the minus 13 centimeters in diameter. That means across the nucleus. So that's like 0.0000000000001, really small centimeters. The atom itself is 10 to the minus 8 centimeters in diameter. So we can see the nucleus is really small compared to the atom. So tiny nucleus. And atoms, of course, are tiny themselves. So nuclei are really small. And that brings us to the subatomic particles. Let's summarize what we've learned so far in this chart. We have electrons, protons, and neutrons. Those are particles that make up the atom. They are called subatomic particles. Electrons are an E- because they have a -1 charge. They're located outside the nucleus. Protons are a lowercase p plus. They are inside the nucleus. They have a +1 charge. Neutrons are a lowercase n. They are neutral neutrons, no charge. So 0 charge. They are also inside the nucleus with the protons. Now, as far as their mass goes, we're going to make up a unit called atomic mass unit. We're going to let protons and neutrons be about 1 atomic mass unit. Okay, so proton, neutron, put them on the scale, they weigh 1 atomic mass unit. But electrons are little bitty tiny things. When you put them on the scale, they barely register. They're 1,836 times smaller than a proton or a neutron. So basically 0 weight for them in comparison. So we call that negligible. It's like if you rent an apartment and you go to your landlord and say, I have a penny to pay towards my rent, but I don't have the rest of it yet. Do you honestly think the landlord's going to take that penny? No. Penny is negligible for your rent. It doesn't really matter. It's not enough to be worried about. Well, the electron's mass is basically negligible in the atom. It's practically 0 because it's so small. All right, I hope you enjoyed this video. We'll continue with the rest of the chapter in another video. Thank you very much.